Alright, back with one last question before you all go off to bed. This is exercise 22b, question 13. I'm going to do this one because it's a fun one. The illustrated curves are those of y equals sine x and y equals sine of 2x. Identify each curve. Alright, well we know that the number in front of x multiplying x compresses, horizontal contraction or compression. It's going to compress the curve so that the period would, instead of being 2 pi, would be 2 pi divided by 2 or just pi. Quite clearly then, C1 corresponds to the sine of 2x, so we can write that in. This one is y equals sine 2x. It's going through the x values twice as quickly as the other one. So it's been squashed and compressed. The other one, of course, is y equals sine x. Alright, we've done the first bit. Let's have a look at part B. Find algebraically the coordinates of A. Now A is obviously where they intersect right there. So how am I going to do that? Well, pretty easy. I'm going to go with sine x equals sine of 2x. Okay, that's pretty easy, straightforward. Now, we've got some rules for the sine of 2x, and the rule that we're going to need to go with is sine x equals 2 sine x cosine x. Now, these double angle rules, the sine 2x is sine 2 sine x cosine x, and the cosine 2x, 2 cos squared x minus 1, 1 minus 2 sine squared x. You can write them down on your summary sheet and have them there. If you needed them, you'd probably be given them in the exam because they're not necessarily that well known, but we might just say, given that sine 2x equals 2 sine x cosine x, go ahead and do this question. So you've got to be comfortable doing it anyway. If I'm trying to solve this, whenever I've got products or things and I want to solve these, the danger is people will hear divide by sine x, which is very tempting, but don't do that. Remember, we want to get it equal to 0 and factorize to solve these things. Minus sine x there. So that's pretty straightforward. Now all we've got to do, factor out that sine x, and I've got sine x, or I've got 2 cosine x, take 1. Alright, null factor law, sine x equals 0, or 2 cosine x minus 1 equals 0. Over here, where is sine x equals 0? Let's get our little best friend in maths out, very tiny one. That's okay, we can have small people for friends too. All students take crack. There we go. They shouldn't be doing that though. All students try courageously in their maths exams. Isn't that much nicer? Alright, so where is sine equals 0? Obviously, this is my sine of x, or sine of theta axis. If that's sine of x, then it's 0 over here at the start, and over here. So we've got 0, pi, and 2 pi radians. You can see here, we only need to go up to pi though, so x is going to equal either 0 or pi for the domain that we're going to be looking at in part C. So that's fair enough. This other one here, 2 cosine x minus 1 equals 0, so that's the same as 2 cosine x equals 1. Cosine x equals a half. And we've got our best friend. Let's bring out our best friend's little buddy. It's always nice to ask your best friend's friends along too. It's nice of you to invite them along. 1, 2, root 3. This angle here is the small one, so it is pi over 6. This angle here is opposite the longer side, so it's a larger angle, pi over 3. We're doing cosine, so it's adjacent. The adjacent side would be 1, and the hypotenuse would be 2. So x is going to equal pi over 6. Now, we've got to identify A, where these two things are equal. They're obviously equal at 0, at pi, and this is the other one we wanted. So we know that that point there is going to be pi over 3. I said pi over 6 before. What was I doing that for? Pi over 3. We went to the whole trouble of saying pi over 3. I was probably thinking ahead to the next bit and not concentrating well enough. Let's go back and change that. I could hear, though, it was echoing in my head that I'd said something incorrect. So, at least we've gone and picked it up. And that's what you should try and do in your exams. Try and pick up when you're thinking one thing and writing another, because you're getting too excited about doing all this maths. Alright, so we found pi over 3. They actually wanted the coordinates of A, though. So what are the coordinates of A? It's pi over 3 And then the sine of pi over 3. Now the sine of pi over 3 is root 3 over 2. So pi over 3 and the y coordinate would be root 3 over 2. That would be the coordinates of A. So to find the total area enclosed, we're just going to have to do the integral from 0 to pi over 3. And it's the top one minus the bottom one. So that's going to be sine 2x minus sine x. dx plus the integral from pi over 3 to pi, and in this case the top one is sine x, so that's going to be sine x minus sine of 2x dx. Now if I were you, from here I would go to my calculator. I'm going to use Desmos because I don't have a calculator on this, but you can use your calculator to find the area here pretty quickly. So let's go ahead and do that now. Alright, well I think I said I was going to Desmos, but I went to Wolfram Alpha because I forgot that Desmos doesn't actually do integrals for us yet, but I think they're working on it. Definite integral from 0 to pi over 3 of sine of 2x minus sine of x. So the first bit there is equal to 1/4. The second part of the integral from pi over 3 to pi is equal to 9 over 4 or 2 1/4, which means our total area between the curves shown there, the shaded areas combined, is 2 1/2 square units, or units squared, however you want to write it. And there we have it. So again, that part C, that'd be calculator work. The rest of it, bit of trigonometry and a bit of remembering what we've been doing. Alright, good luck with everything, guys. Make sure you get plenty of sleep, and you'll be fine tomorrow. See ya.